Hello, it's Keith here, and this is lesson 2 of the platform-specific series of my Easy80 assembly programming tutorials. Now, last time we looked at the 16-bit color screen on the Ti-84. This time we're going to create the same Hello World example on the 16 color 4-bit per pixel screen. So if I just start my program up here, we'll see it in action. Basically, what we're going to do is the exact same example as last time, but this time we're just going to use the 16 color screen. So we've got our Chibiko again, and we've got our memory dump here. This is just my monitor test tool. You'll see the background is a little bit corrupted. Well, why is that? Well, because the rest of the VRAM is still containing the 16-bit per pixel 32K color data. Now, why would you want to use 16 colors when we've got so many more on this system? Well, a simple reason is memory limitations. We can't use very much memory for our programs. Our programs need to be quite small, and we certainly don't want to be storing 32K 2 byte per pixel data when we could store 2 pixel per byte data, because let's face it, on a system like this, 16 colors is quite adequate for most purposes if we're trying to write little games. So that's what we're going to be doing today. We're going to be creating this example. We're going to learn how to do it. Now, the first thing we're going to discuss, though, is how we actually got the bitmap data. So here is my Chibiko mascot. This is the graphic that we are using in today's example. You can see it just there. And now that's the battery indicator has now appeared and messed up the graphics. Quite annoying. The system really doesn't know we're in 4-color mode, which it's an issue. We have to turn it off before we finish. Anyway, so here's the 16-color bitmap. You can see the 16 colors here. How do we export this? Well, if we go to the Z80 menu here, and if we go to Ti-83, Ti-84, we have got a save Ti-84 bitmap 4-bit per pixel here, and we've also got a palette to clipboard option, and that will output the palette in the correct format for today's example. So that's what I've used to create the data that we needed from the bitmap, the Chibiko bitmap, and that's what we're going to get onto our screen. So let's go over to the source code and let's take a look at what's changed. Okay, so here is our program. I'm not going to discuss the basics of getting a program running on the Ti-84. We'll discuss that in the Hello World series. What we're going to discuss today is how we're actually getting the screen set up and getting the bitmap data to our screen. So the first thing we need to do is we need to change the mode register, which is a memory map register, at E30018, and we have to send 2 bytes to this to define our screen mode and the settings of the screen. So here is all of the data. Now, the only bit we're going to be discussing today is these 3 bits here that I've marked with an M here. These are the screen mode, and this selects our bit depth basically, and so we can specify our bit depth using these bits here. So a value of 0 would be a bit per pixel of 1, so just black and white. A value of 1 would be 2, and a value of 2 would be 4 bits per pixel, and that's what we've specified here. 4 bits per pixel is 16 colors, so we are enabling 16 color mode with these options here. Now, the important thing is when we finish, we need to turn the screen back to the way it was. Otherwise, when we return, we will actually end up corrupting the screen. So if I just run my program here and I just start it up here, you can see that this has run fine, but when we return, everything goes back to the way it was. So we've got our normal screen, and you actually saw a little bit of corruption at the top of the screen, and that is the remainder of my my Chibiko bitmap there. It's still in screen memory. Now, if I disable this line here that was restoring the screen and I run again, now if I run this way, so we've got our Chibiko, it all looks well here, but if I press a key, well, what's that? That's the operating system. We've returned back to the operating system, but because we've gone direct to the hardware, the operating system has no idea what we've done. Now, there are various functions within the operating system to do things relating to the screen, but in my tutorials, I like to go to the hardware. That's the way I like to do things. I enjoy learning how the hardware works and playing with it, and I don't enjoy learning about how operating systems work so much. So that's why I've made the choice to do things this way. Okay, so that's how we set our screen mode up, but unlike with our 32-bit color screen, now our bytes won't define the entire color, so we need to define the palette for the 16 colors we want to use. Now, I've created this palette data here. This is the palette data that we need. Now, this is in red, green, blue format, so basically there are 5 bits for red, 5 bits for green, 5 bits for blue here. And so each of these words, these 2 bytes here, is one of the colors, and the format is slightly different to the screen format. The unused bit is in a different position, but basically these are defining the colors, and this was exported with that option in Sprite editor to export the palette data. So I just pasted it straight in, it puts it in the clipboard. So these are the colors that the Chibiko graphic requires, and that's why the text is a different color. It's using color 1 this time, so that's not yellow, it's a slight orange. Okay, so that's what we are using for our palette, and to set up the palette we write to a different memory mapped register. E30200 onwards define the colors, so we need to write 16 bytes times 2, so 32 bytes total for the 16 colors, and we write from that address onwards. So we're specifying this as our destination in DE, the palette as our source in HL, and BC is the 16 colors times 2, 32 bytes, and we use LDIR to transfer our palette to the hardware registers to set up the colors. Very good. So now we've got our screen set up and we've got our colors set up. So first thing we're going to do is we're going to test our sprite. So we're going to transfer our sprite data to the screen. Now our sprite here is this file here. We're importing it as raw data here. That was again exported with Sprite editor. Very simple. All we're going to do is we're going to transfer our source sprite to our screen memory, and our screen memory is D400 onwards. Now each line is 320 pixels, but there are now 2 pixels per byte. Our Chibiko bitmap is 58 pixels, so we're drawing that image at the far right of the screen. The far right of the screen is 320 pixels across, so we're subtracting the width of our bitmap, and so we're doing 320 pixels minus 58 pixels, dividing that by 2 to convert it to bytes, and adding that to the screen base there, the VRAM base. So that's the start of our graphic. Our graphic is 54 lines tall, and it's 58 pixels wide, but divided by 2 to get that in bytes. So here we are transferring 1 full line from our HL source to our DE VRAM destination. And then once we've done that, we're moving down a line. So how do we move down a line? Well, we're restoring the VRAM destination for the start. So we're basically moving across, jumping back, moving across, jumping back. We're drawing our graphic in that format. So what we're doing is we are adding enough byte data to move us down 1 full line. 320 pixels divided by 2 is the number of bytes in each line. And we're just repeating until we've done all 54 lines of our graphic. That's how we get the bitmap to the screen. Very easy, really. Okay, so that's how we're drawing our bitmap. What about when we're drawing characters to the screen? Well, we have our font. Our font is 1 bit per pixel, that's black and white. And basically, we are going to use this and we're going to convert it to 4 bits per pixel. We're going to bit shift the bits as we read them out from the font. Each character in our font, because it's 1 bit per pixel, is 8 bytes, and the first character is a space. So we need to adjust. We're going to pass an ASCII character to this print char routine, but we're going to convert it and calculate the memory address for the character. So we're subtracting 32 to calculate the first character in our font. We're then multiplying that by 8 and adding that to our font base. That's the file exported by Sprite editor, which is the font file for our graphics. We're also using this getScreenPos function to calculate the VRAM destination. Well, how do we calculate the VRAM destination? Well, it's pretty straightforward. Our screen base is D400. Each of our lines is 320 times 8 divided by 2. Why is that? Well, we're using an X and Y positioning characters here. So each of our lines is 320 pixels, but each block of characters, 8 lines tall, is 320 times 8, and of course 2 pixels per byte, so dividing that by 2. So we're multiplying our Y pos by that. We're multiplying our X pos by 4 because there's 4 bytes for 8 pixels, so that's why we're doing that. And we're adding it to D400 to calculate our VRAM destination. Okay, so we've now got our source font and our destination VRAM. So what we're going to need to do is we're going to need to transfer 8 lines and 4 bytes of screen data for our font. So for each byte of our VRAM destination, we're going to need to use 2 bits of our font source because it's 1 bit per pixel source, 4 bit per pixel destination. So what we're doing here, so we're moving a byte out of our font into C here, and we're shifting 1 bit out of our source, shifting it 4 bits, and then shifting a second bit out of our source, and then shifting it 4 bits, and then we are transferring that to our DE destination. So we've now used 2 bits of our source, and we've written 1 bit to our screen. That's what we're doing here. And we're repeating that 4 times to do the remainder of the line of our font. Once we've done a line, we're then moving down a line with get next line here. That's very simple. Again, we're just adding the number of bytes in a line of our screen. 320 pixels divided by 2 equals 160 bytes. So that's moving us down a line. We're then just repeating until we've done all the lines, and we're just moving our X position across one character for the next time we want to draw. And that's really all there is to it. So that's how we've got our bitmap graphic to the screen here. Let's see it just one last time for posterity. So there we go. So that's how we've got our Chibiko graphic to the screen, and that's how we've drawn these other characters. So there we go. So that's all we're covering today. Now next time we're going to be doing another episode on the Ti-84. We're going to look at a simple Hello World example, and we're going to learn how to compile it and run it on our emulator. So if you need to see all of the stages in doing this, then please take a look at that. If you want, you can go to my website and download my source tools and my build scripts. The only thing is I can't provide the ROMs for the emulator because of legal reasons, so you'll have to provide your own ROMs. I'm sorry about that, nothing I can do. Anyway, hope you've enjoyed this. Thanks for watching and goodbye.